All right, so we got a request to do some regression analysis for OPRE 3360. The request came with the following problem. You guys can maybe pause the video for a minute if you want to read it. Basically, we have a company and they are trying to determine how um, the amount that they spend on advertising affects their sales. This problem came with some data, which I've already inputted into Excel over here. And right now what we want to do is we want to use Excel to get the equation of for our regression model. Now, we're trying to see how advertising affects sales. So advertising is our independent variable, our X, and the sales would be the dependent variable, which we represent as Y. Okay. So the first thing I'm going to do is, I think it's nice to get like a little scatter plot of our data. So I'm going to highlight or select all of the data right now in Excel. Remember that we wanted advertisement spending to be the independent variable X, sales to be the dependent variable Y. Okay. So you want the X column to come before the Y column. That's much easier. So now I'm going to go to Insert. I'm going to go here to create a scatter plot, okay? Okay. And I want to go ahead and add our uh, regression line to this plot. So I'm going to go to trend line. I'm going to click on this triangle to get some more options. And I'm going to go down to here again for even more options. Okay. So Excel, you can do a couple different fits to the data, but here we're just doing a standard linear fit. So we have the linear option selected. And I'm going to go ahead and display the equation of that line on the chart. And maybe we'll display the R-squared value as well. Okay. Okay. So here, this equation of this best fit line, that would be the equation of our regression model. So let's see here. The equation was, let me see if I can maybe copy paste it. Oh, well, okay. I wasn't quite planning to copy the entire scatter plot, but I guess that's okay. So here we see that our equation is y equals let's see here, negative 0.0712x plus 4.3135. Okay. So now looking at these four answer choices. Okay, so looks like answer choices C and D are the closest options, but because they have the same numbers, but the correct answer choice would be C though. So got to be a little bit careful, but so negative 0.0712 should have been the slope or the coefficient of the independent variable. So here you have negative 0.071 times advertisement spending, which was the independent variable for us. So this equation matches our equation that we have over here then, okay? So this one's wrong because they have 4.314 as the coefficient, but the coefficient should have been the negative 0.0712, okay? All right, so correct answer should be C, okay? Now we want to figure out whether our regression model is, I guess, statistically significant. And you can't figure that out just by looking at the scatter plot and everything here. So what we're going to have to do now is I'm going to come back to Excel. And we're going to run a regression analysis on the data. So to do that, I'm going to go to Data now. And here I have this data analysis option. So for those of you who are watching this video and you might not have data analysis as an option when you go to data. So if that's the case, you would have to go to Files, and then you'd have to go to Options. For me, I guess I have to click on More, and then I have Options as an option. You go to Add-ins. And so here I have the Analysis Toolpack as an active application add-in. So if you don't have that, then you have to activate it. I think you go to here and there you go. You'd have to check the Analysis Toolpack box. I'm not sure about the difference between the Toolpack and the Toolpack BBA. I just went ahead and selected both of them. But after you check those boxes, the data analysis option should appear. Okay. So we're going to click on data analysis. And we're doing regression, so I have regression selected right now. Okay. So for the variable y, you want to select sales for the variable y, the dependent variable. For x, you want to select the advertisement spending, so just select all of that data. The labels box, okay. So I'm going to select the labels box because when I was selecting all the data, I happened to select the labels for x and y. There's other stuff here, but I don't think it's important at the moment. So I'm just going to leave those boxes unchecked. And then let's output the data in cell F3. Okay. I'm going to hit OK. All right, so here we got a bunch of data. So I'm going to try to get this data in. Okay. So just save the data, and I'm just going to put the data in here now so I don't have to keep switching back and forth. Okay. All right, just give me a second to fiddle with everything here. Okay. So let's look at everything that Excel outputted for the regression analysis. Okay, so first, maybe it's worth noting when you go down here and look at the coefficients. Okay, so the intercept was like 4.3135, so that refers to the y-intercept of our regression equation that we found from the data. And then the coefficient for ad spending minus 0.071. So notice that was the slope of our linear regression model, okay? So you could have found these two numbers from doing the regression analysis, okay? Rather than getting them from the scatter plot. R squared, in the scatter plot, we got it was 0.5906. Maybe worth noting you could have gotten R squared value from the regression analysis as well, okay? All right. Now, to answer this question, so this question is basically asking whether our regression model is statistically significant. So to answer that question, you want to look at this ANOVA output, okay? And particularly, you want to focus on this number here. So this number is the p-value. And here we see that the p-value is much smaller than our level of significance being 1%, okay? So that p-value is much smaller than 1%, 0.01. And so because the p-value is smaller than the level of significance, that means that our regression model is statistically significant, okay? All right, so what exactly does that mean? Well, looking at our regression equation over here, so notice that there's a negative slope, okay? And the negative slope indicates this tendency that the more they spend on advertising, the worse their sales are actually, okay? So the more they spend on advertising, the lower their sales end up being. And since our model is statistically significant, that means there should be statistical evidence that the increased advertising spending will actually decrease sales. So increased ad spending decreases sales. That would correspond to answer choice A then, okay? So the reason why there is statistical significance is because the p-value was smaller than our level of significance. Okay, so that's why there was statistical evidence, and then the negative slope indicates that an increase in advertising spending actually leads to a decrease in sales. Okay. All right. So let's take a look at question C. So do you consider the estimated model to be acceptable for further analysis? Well, I'm not 100% certain how to answer that question immediately, but let's see if we can eliminate some of these answer choices. So the p-value for the F statistic is too high. That's definitely false, okay? We kind of just talked about that. The p-value for the F statistic is actually quite small, smaller than our level of significance. Okay, so I would definitely say that one's wrong. The p-value is not too high. Okay. No, because the r-squared value is too low. Okay. R-squared is about 59%. So r-squared value is always going to be a number between 0 and 1. The r-squared value roughly represents the r-squared value represents like how much your model explains the variation in your dependent variable. So the closer your r-squared value is to 1, the better your regression model is. And the closer the r-squared value is to 0, the worse your regression model is. So an r-squared value of 0.59 is not very high. It's not that low either. So saying that it's too low, that's a little bit subjective. So I'm not sure if we can eliminate that answer choice at the moment. It's not super low, but it's not super high either. Looking at answer choice C, so no, because the coefficient of the independent variable is insignificant. So the independent variable was the ad spending, and we know the coefficient was the slope, so minus 0.071. To figure out whether it was significant or not, you can determine that by looking at the p-value for the independent variable, okay? So this was the p-value for the F statistic. This was the p-value for the independent variable. Well, for the coefficient of the independent variable, which would be the slope, okay? And here you see the p-value 0.0005. That's also an extremely small p-value. It would be less than a 1% significance level as well, okay? So it's a very small p-value, and that indicates that the coefficient is definitely statistically significant, okay? In particular, what it means for the slope to be statistically significant, basically it means we can reasonably conclude that the slope is not equal to 0. But the output over here suggests that the slope is significant. This answer choice is saying that it is not significant. So this answer choice should be wrong, okay? Answer choice D, so yes, because the r-squared, all the relevant p-values and the stated errors are all in acceptable ranges. So I would probably say answer choice D is the right answer. Okay. Your r-squared value is not that high, but it's not that low. So I don't think you could argue it's too low. So I suppose the right answer would be that everything is in an acceptable range. So I'd go with answer choice D. Okay. All right, looking at question D next. So for week 17, we know that they're planning to spend 26,000 on advertising, and then we want to estimate what their sales are going to be. So let me go back to Excel for that. Okay, so for week 17, They're planning on spending 26,000 on for advertising. And now what we want to do is we want to use our regression equation to estimate what their sales will be, okay? All right, so we know that this was our regression equation, okay? We're saying X, the advertisement spending, is 26. And based off that, we want to estimate Y, the sales. So all we need to do is plug in 26 for X into our equation. And then whatever our equation returns for Y, that would be our estimate for the sales, okay? So let's compute that in Excel right now. So I'm just going to take, so the slope of our regression equation was this number here. Oh, whoops. I'm going to take the slope times, we're plugging in 26 for the X value in our equation. We have to add the intercept, which was this number. So 2.46 should be the right answer. So answer choice B, okay? So our regression model predicts that their sales will be about $2.46 million if they spend 26,000 on advertising, okay? Now lastly, let's see here. So now they're asking about if we wanted to come up with a 95% confidence interval to estimate the sales for week 17. So in part D, we came up with a point estimate for their sales in week 17. But instead of providing a point estimate, you might prefer to provide a confidence interval estimate instead. So instead of providing a single number as your prediction, you would provide a range of possible estimates using that confidence interval. And so if you were to do that, they're asking what would be the standard error that you would use to construct that confidence interval. Okay. Looking at the output over here, so you might notice there's a couple of different standard errors that they list. There's a standard error over here, and there's also standard errors down here. Okay. Incidentally, all three of them appear to be an answer choice. Okay. So these two standard errors, these are the standard errors for if you are trying to estimate the intercept or the slope of your regression curve. They wouldn't be the standard errors that you would use to estimate one of your um, to estimate the sales, if you will, for a given week. So these two standard errors are incorrect. This standard error is therefore probably the correct answer. Actually, I noticed now that 0.5614 was the adjusted R-squared value. Okay, but the adjusted R-squared value, I don't think that would be the standard error that they're looking for. Let's see here. I'll do a quick computation just to check something. If I did that times, oh, I would need this. Okay, yeah, okay. So the standard error that they provide up here, I suppose that would be the standard error that you would have to use then to compute well, for your confidence interval to estimate your sales for a given week. Okay. So yeah, so you'd want to use the standard error that they provide up here if you were trying to get a confidence interval to estimate your dependent variable, in this case sales, in this case for a given week, okay? All right, so that's just going through all the questions that were requested. So hopefully you guys kind of saw how to do regression analysis in Excel and how to interpret some of the numbers that they output in the end, okay?